Hey guys, welcome back to my channel. In today's video, we're going to see how to solve this problem called minimum number of pushes to type verb to. Okay, so the question is a bit lengthy. It seems lengthy, but it's not lengthy actually. I'm not going to read the question. I'm just going to say the key points and then let's solve the question. Okay, so see, what the question says is basically the question will be giving a word, right? Let's say A, B, C, D, E. And let's say you have a keypad phone, and in that keypad phone it's given something like this, like two in the two key A, B and C character is there, in three D, E and if character is there, right? So if you want to press E, you have to press two times three key, right? Similarly, you have to imagine that you have a keypad and then these characters you have to type, right? So let's say A, B, C, D, E. So in this keypad, if I want to type A, B, C, D, E, how many pushes or how many press that I am going to give? One for A, then for B, again one time. I will just press 3 one time so that B will be printed, right? And for C, I will press 4 one time. And for D, I will press 5 one time. And for E, I will press 6 one time, right? So total number of presses are 1, 2, 3, 4, 5, 6. That is 5 times. So the answer is 5. But the twist is the keypad is not given to you. The keypad is not given to you, and it's not necessary that it's in this format. See, in the actual phone it is actually ABC, but here it's AFG, right? So you can basically shuffle all the characters, right? But there is some conditions. What are the conditions? You can do the remapping, but all these keys should be having total number of distinct characters, right? What I meant to say is, like, if AFG is there, then A should not be repeating in any other key, right? Overall, the total number of characters should be unique or it should be distinct. So what you have to find is the minimum number of pushes that you have to do, or the minimum number of press that you have to do in order to print this word. And you can take any keypad orientation by your own. The main task is to rearrange the characters in such a way that you can write the word in the minimum number of pushes. Also in the question, it is mentioned that you can only use the keys from 2 to 9. That means you cannot use 1, star, 0 or hash, right? So you need to use only 8 keys, total number of 8 keys, that is from 2 to 9. And you have to rearrange those characters in such a way that the word that is given to you is printed in minimum number of pushes. So let's take an example and then see like how we go about this, right? So let's say 1 is not allowed to use, and even this star, 0 and hash is not allowed to use. These all are these empty keys. That means we haven't assigned any characters to those, right? So let's say this is the word. This is the word that is given to me. The first letter is A. So let's say I am placing A here, and the next letter is B. So where should B be placed? So ideally, for getting A, I should press one time which key? 2, right? So next time I have to get this B. So should I give this B here or here? Here. Why? Because see, to print B, I have to press 2 times, right? Here I have to press 2 times, but here I have to press only 1 time, right? We have to get the minimum number of presses. So I'm writing A here and I'm writing B here so that B will be printed in a single press. So in a single press, I can print B. So for that, I have to press 3, right? So similarly, for C, I'm going to give it here. So that C will be print by pressing 4 one time, right? Similarly, D I'm going to give it here, E I'm going to give it here, F, G, H I'm going to give them here, right? F, G and H. But here, when I came here, I have to print I. But all these keys are filled with single characters, right? So can I press I by giving a single press? That's not possible, right? Why? Because all these keys are already filled with a single character. That's the reason. So what I'm going to do, I can write I here also, I can write I here also, I can write anywhere, right? So let's say I'm going to write this I here, let's say. So when I go to J, where should J be placed? J should be placed here or somewhere else. I shouldn't place J here because why? Because to print J, I have to click 2 3 times, right? So I don't want that. If I can print J in lesser number of clicks, right? So I'm going to place J, let's say here. Let's say here. These characters are printed in one click, and I and J is printed in 2 clicks. Similarly, K is also printed in 2 clicks. Why? Because K can also be assigned here, right? And similarly, L I can give it, let's say here, M I can give it, let's say here, N I'm giving it here, and O I'm giving it here, let's say. So the first 8 characters I can print in a single click. So total clicks is 1 into 8, right? And these characters I can print in how many clicks? I can print in 2 clicks. So 2 into how many number of characters are there? 1, 2, 3, 4, 5, 6, 7. So 2 into 7. So 1 into 8 plus 2 into 7 will be my answer. Okay, so this much is clear, but let's try to understand a special case, right? So let's say this O is appearing, let's say 4 times. 4 times. So in this way, I have to click how many times to print these many O's. I have to print 4 into 2 times, because for printing each O, I have to click 2 times. So 2 into 4, it will be 8 times. So in order to print O, I have to click 8 times. Let's say if O was written here, instead of A, it was O. So in order to print O, I only need to give 4 clicks, right? So can I say that I need to replace this O with this A? But you might argue that, okay, bro, that is fine, but A will come here. No, A will come here. So even if I can print all the O's in 4 keys, A will come here. So to print one A, I need to give 2 clicks. That is true. But the total number of clicks is 2 plus 4, that is 6, which is still less than 8. Rather 8 plus 1, because 1 is to print this 1A. So to print 1A and 4 O's in the normal way, it will be 1 plus 2 into 8, that is, 2 into 4, that is 9, right? If we swap it, it's 1 into 4 plus 2 into number of A's is 1, so 1. This will be 4 plus 2, that is 6. It's anywhere lesser than 9. What we need to take care is that the maximum number of frequency elements or the characters that should be placed at first, so that I can focus on minimum number of clicks for the maximum number of frequency elements. So this algorithm is correct, but we have to do one modification, that is we have to sort it. We have to sort it according to the frequencies of each character, right? This O should be coming at first, because we are sorting in descending order. So the larger the frequency is, the lesser the number of tabs should be, right? So if O is there 4 times and all the other characters are there only 1 time, so O should be placed at the first, so that the total number of clicks are minimized, right? So now let's look at this example. So this is our final example. Let's count the frequencies first of all, right? So in order to rearrange, we have to find the frequencies. So for A, the frequency is 2. For B, the frequency is 2. For C, it's 2. For D, it's 2. So for these all, it's 2, right? This also 2. But for I, it's 6. For I, it's 6. So the frequencies are 2, 2, 2, 2, 2, 2, 2, 2, and then 6, right? So 8 twos and 1 6. So right now I don't care about what the character is. I got to know that how many number of times that character is present, right? So here one character is present 6 times. So I want that 6 to come at first. So I'm going to sort this and then write, right? So after sorting this, 6, 2, 2, rest everything is 2. So from 0 to 7th index, that means the first 8 characters we can print in one click, right? So the total number of clicks will be 6 into 1, 2 into 1, 2 into 1, and then do the summation of all these, right? And from here, from 8th index onwards, that is from 9th character onwards, we have to give 2 clicks. So from here, 2 into 2 will be coming. Let's say there are so many other frequencies, right? So let's say the next 8 characters are also filled. So then we have to fill the third place. So the number of clicks for these will be 3. So let's say x was here. So x into 3 will be added. So since there is only one character, we don't have to take care of this, right? But if there were more, then after 8 more characters, that is from 16th character, clicks should be 3. Right, so the question is very simple. We just have to take the frequencies and then we just have to sort it, and after sorting, we just have to divide them into groups. So the first 8 elements should be placed at these places. Let's say this is the keypad. So first 8 elements 1, 2, 3, 4, 5, 6, 7, 8. And next 8 elements will be coming here. 1, 2, 3, 4, 5, 6, 7, 8. So these elements need 2 clicks. And the next 8 elements need 3 clicks because they are in the third position. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So that's how we approach this problem, right? So now let's look into the code. So first of all, I'm going to count the frequencies, right? I'm going to count the frequencies of all the characters. And now I'm going to sort them in descending order by the frequency counts. I'm going to store this frequency in a vector called vec. And then I'm going to sort this vector in descending order. So that's the reason I give R here. That is reverse begin and reverse end. So here is the main part. Here I am going to count the number of total press that is needed. So this count will take care of total press, and this press will take care of how many press should I give for that single character, right? So from 0 till 7, the press should be 1. So initially it is 1. And the moment this I is divisible by 8, that means when it comes to 8, the press should be increased by 1, so it should be 2. And again after reaching 16, from here onwards, the press should be increased by 1, that is 3. And for each of these characters, I'm going to get the frequency into number of presses. Okay, it's not MUL, it's press. So vec of I, that is the frequency, into press will give the total number of press that is needed for that particular character. And at the end, we just have to return the total number of press that we took. So coming to time and space complexity, let's calculate, right? So here the space is of 26. Why? Because at max the characters will be 26 characters, or I can say number of distinct characters, but at max, let's say k is the number of distinct characters. This k can be 26 also, because let's say all the characters are distinct. So there are 26 alphabets. So this frequency will be containing at max of k space. This can be simplified into O of 26. So O of 1, given that only 26 characters are there. If this was not given, it will be something like O of n if we generalize it, where n is the total number of characters in word. So we are using this frequency a space, and also we are using a vector, but inside this vector we are just storing the frequency only. So this also will be of k. This also I can write it something like of k plus of k, but this 26 was not given, then of n plus of n, right? Now the time complexity will be, this will be running for n times. What is n? Number of characters in word. This sort is taking a time of n log n, and this loop will be running for k times, and this also will be running for k times. So time complexity will be of n plus of k plus n log n, rather k log k plus of k. But considering all these space are constant, why? Because 26 is given, time complexity will be of n. But if the 26 was not given, overall time complexity will be of n log n. So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.